Chapter 1: The Perfect Cosmic Trap. Black holes aren't giant cosmic vacuum cleaners. If our sun magically became a black hole while keeping the same mass, Earth would continue orbiting almost exactly as it does today. So why are black holes so terrifying? Because of gravity. When a star many times more massive than our sun reaches the end of its life, it can no longer support its own weight. Its core collapses in an instant. The explosion creates a supernova. But the core continues collapsing until an enormous amount of mass is squeezed into an incredibly small region. Gravity becomes so intense that even light cannot escape. That's why we call it a black hole. Surrounding every black hole is an invisible boundary known as the event horizon. Cross this boundary, and there is no known way back. Chapter 2: The Point of No Return. Now imagine your spacecraft drifting closer. At first, nothing looks unusual. The black hole itself is completely dark. But around it, glowing clouds of gas spin at incredible speeds, heating up to millions of degrees. The closer you get, the more reality begins to change. Your watch continues ticking. Your heartbeat feels normal. But someone observing from far away would see something astonishing. To them, you appear to move slower and slower. Your signals arrive farther apart. Eventually, you seem frozen at the edge of the event horizon. You never appear to fall in. Who's correct, you, or the observer? According to Einstein's theory of general relativity, both are. Gravity doesn't just bend space. It also changes the flow of time. Near a black hole, time behaves differently depending on where you are. Chapter 3: The Most Painful Stretch. Now gravity begins to reveal its true power. The force pulling on your feet is stronger than the force pulling on your head. At first, the difference is tiny. Then it grows. Your body starts stretching, longer, thinner, every second. Scientists call this effect spaghettification. It's caused by tidal forces, differences in gravity across your body. For smaller black holes, these forces become fatal before you even reach the event horizon. But here's something surprising. Supermassive black holes behave differently. Because they are so enormous, the gravitational difference at the event horizon can actually be much smaller. You might cross the point of no return without noticing anything unusual, at least for a while. Chapter 4: Inside the Event Horizon. Now you've crossed the event horizon. There is no alarm, no explosion, no bright flash, but something fundamental has changed. Every possible path through space now leads in only one direction, toward the center. No engine can save you. No signal can escape. Even light is trapped. This is where physics enters unknown territory. At the center lies what physicists call a singularity. According to general relativity, matter is compressed to an infinitely dense point. But most physicists don't think nature literally contains infinities. Instead, they believe our current theories are incomplete under these extreme conditions. To understand what really happens, we would likely need a successful theory of quantum gravity, a theory scientists are still working to develop. Chapter 5: The Paradox That Confused Science. Imagine bringing a book with you into the black hole. Every page, every word, every atom, disappears beyond the event horizon. Does that information vanish forever? Quantum physics suggests information should not simply be destroyed. Yet black holes seem to hide it completely. This conflict is known as the black hole information paradox. It became one of the greatest puzzles in modern physics. Stephen Hawking spent decades studying it. Today, many researchers think the information may somehow be preserved, but there is still no universally accepted explanation. The mystery remains open. Chapter 6: What if black holes aren't the end? Some theoretical models suggest black holes might connect to other regions of spacetime. Others explore the possibility of wormholes. These ideas are fascinating, but it's important to be clear. There is currently no direct evidence that black holes are portals to other universes or dimensions. For now, they remain speculative possibilities rather than established scientific facts. Even without those theories, black holes are extraordinary. They push gravity, space, and time to their absolute limits. Black holes are more than mysterious objects in space. They are natural laboratories where the universe tests the laws of physics in ways we still don't fully understand. Every new observation, every new telescope, every new discovery brings us one step closer to answering questions that have puzzled humanity for generations. Somewhere in the darkness of our galaxy, Millions of black holes continue their silent existence. Invisible, powerful, and filled with secrets waiting to be uncovered. So here's a question for you. If you had the chance to travel to the edge of a black hole, knowing you could never return, would you go? Let us know in the comments. And if you enjoy exploring the mysteries of space, science, and the universe, subscribe to the Unseen Facts, because the greatest discoveries are still waiting to be found.